Dear friends, welcome to this electrical engineering knowledge sharing channel, AMP Power System. We are discussing about the switchgear control schematics under workshop 8, and in this workshop we have already completed 6 sessions, that means 6 videos. So today we are discussing about the session 7, video number 7 under workshop 8. In this video or in this session 7, we'll be discussing about the indications and alarm requirement for the switch gears. Now, indications and alarm system requirement comes into play to monitor the switch gear two operating condition. One operating condition is a healthy operation condition, another is an unhealthy or abnormal or faulty operating condition. To monitor these healthy operation and unhealthy or abnormal operating conditions, switchgear is provided with various indications and alarm system. Normally, indications are provided by the indication lamps, and alarms are provided by annunciator. In the old days, we used separate discrete circuits for the alarm and indication. Alarm along with this indication, because alarm system contains alarm as well as indications, but the indication system, healthy operation, which is monitored by indication, that is only monitored by the indication lamps, but the abnormal operating condition is monitored by the annunciator system, which contains indication lamps as well as horn or the speaker. But this old days we use a discrete circuit for this annunciator, but nowadays annunciators are available in the modular form. In the different numbers of annunciation you can get it. We call it OA. Like 8 OAs annunciator means it can consider 8 number of abnormal condition, 10 OAs, 12 OAs, 16 OAs, 24 OAs. Various OAs of annunciator is available in today's market. So nowadays we use that annunciator module to monitor the abnormal conditions, and indication lamps we use for the normal or healthy operating conditions. These are the main two classification of the indication and alarm system. Now, when we come to the switchgear, for healthy operation which are important, that condition only we monitor in the switchgear. Number one, we need to monitor the switchgear breaker status, whether the breaker is on or breaker is off or breaker is tripped on fault. These are the three status of a circuit breaker. These three status, when the switchgear is in healthy condition, that means either the breaker is in off position or breaker is in on position, or breaker is on position means and the breaker is operating on the healthy condition, means there is no abnormal condition in the switchgear. That is also we monitored during with the indications. In addition to these three status of the circuit breaker, we already discussed in the closing and tripping circuit two parameters. One is we have seen that trip circuit continuously we monitor, as it is a vital we discussed. So trip circuit monitoring system also under healthy condition we monitor the trip circuit is in healthy condition. That also we monitor under the healthy operation. And another thing we have discussed about the spring charging of a motor, because that is a danger operation. If the spring is not charged, then and spring charging mechanism fails, then you cannot charge the spring. So if the breaker is closed and the spring is not charged or spring fail to charge, then what will happen? Breaker will not able to trip if we close the breaker. That's why before closing the breaker, we need to assure that spring charging mechanism is in healthy condition. These are the three pipe parameters which we normally monitor to monitor the healthy operation of the circuit breaker. In addition to this, there is another parameter normally we monitor which is mainly for the SF6 circuit breaker. We know that if SF6 circuit breaker, SF6 pressure is low, then circuit breaker during tripping there would be a chance of fire. That's why circuit breaker SF6 gas pressure is normal. That is also to be monitored under the healthy operation of the switchgear. So that means there are total 7 or 6, you can say 6 parameter. Normally in case of normal switchgear we monitor 5 parameters, but in case of SF6 switchgear, we also monitor another parameter. These are the normal monitoring parameter by indication lamps, but it is not the fixed. Now, depending on the requirement, if you want to monitor more parameters, you can include those signals also in the indication circuit. That depending on the customer requirement. Like sometimes customer want to monitor the control supply is healthy, that is also they want to monitor. In that case, we have to include another signal. So depending on the requirement, you can include more number of signals. But normally, in general, if we monitor these 5 parameters, then that will consider as a healthy operation of the switchgear. So how we do this thing? In the old days, we use a indication lamp, filament lamp, with a balanced resistor in series with that. But nowadays, with the evolution of light emitting diodes, this old version of filament lamp is deleted. Nowadays, we use LEDs. Now, this LED is a light emitting diode. That is today's technically it is established. It is a well proven device, solid state well proven device. So nowadays, all the indication lamps we are using LED type, and the LED lamps are available in the different color: green color, red color, amber color, is the white color. Differents are available. Normally, when the healthy condition we monitor, we use normally the green lamps. Green lamps, when the green lamps is on, means system, that signal is healthy. But when any of the signal, if the system is not healthy, then we normally use a red lamp. If it is between healthy and unhealthy operation, but there is a abnormal operation, but that is not dangerous, in that case we use a amber color. So red color means it is a danger, amber color means in between it. Suppose the circuit breaker is tripped. So this is a abnormal condition, but that is not danger for the circuit. So that we measure by the amber color. Sometimes we use a white lamp. Suppose a control supply monitoring, we use a white lamp. When the control supply healthy, we monitor by white lamp. So there is a different nomenclature. That nomenclature, which color of lamp to be used, that every organization they have their own specification. So that is specification to be made, but different color LED is available. So depending on the requirement, we can make this. Now we are considering all the healthy operation will be monitoring by the green color of lamp. That is our present scheme. But if a customer want a different color of lamp, that can be done, because LEDs are available with the different colors. Okay. So now let's see how we do this. Now the circuit breaker open status or off status we monitor by circuit breaker NC contact. So we have put a NC contact. Now I have drawn the circuit already. This part is the indication part. This part. And this part is the annunciator part. I have used here, suppose this is 8 ways annunciator. Out of this 8 ways annunciator, I have used 6 ways, and balance 2 ways are balance is SPR. You can consider that I have not shown over here due to space, but you can see the same configuration 2 will be SPR. Now here we have used a 6 indication lamps, but you can include more number of lamps. If you want to include the SF6 gas, we can include that. Let's discuss how first one signal, how it is working. So we have in the case of indication lamp, because it is a solid state device, you know, these LEDs, normally it can take from 1.3 volt to 3 volt. 1.3 volt to 3 volt, normally the LEDs voltage withstand capacity. So you cannot include the high voltage of the LEDs. Then the LEDs will burn, or it will burn itself. And LEDs intensity depend on the amount of current flowing through the LEDs. So these LEDs are very sensitive to the over voltage as well as over current. So these are the LEDs which we have shown over here. It is a light emitting diode. It's called LEDs. These LEDs has a voltage sensitive as well as current sensitive. That's why when we are using the LEDs in a circuit, we have to make sure that LEDs is not subjected to the high voltage as well as high current. Due to voltage fluctuation, high current is not flowing through the LEDs. That is very, very important. So these LEDs, and so this withstand voltage normally maximum 3 volt, and the current flowing through the LEDs, that will decide the intensity of the lamp. But if you pass a high current through the LEDs beyond this capacity, then what will happen? The LED will burn itself on its own. So this is a self danger. So that's why when we connect the LED, we have to consider these two parameters. to reduce the voltage to subject to the required voltage of the LED, as well as the required or the current flowing through the LED should be within its withstand capability. I am coming to that point how we do that. So this, and that's why this, though it is electrical circuit, but this electrical circuit we do not inject the normal electrical control voltage which we have seen in case of closing circuit, tripping circuit, auxiliary relay circuit. We have used 120 volt DC. But for this indication and alarm circuit, we do not use 120 volt DC. We use 24 volt DC. So when we are going to switchgear control supply, in the switchgear there is a multiple level of voltage control supply, DC control supply. One is a 124 control supply which we are using for the closing circuit, tripping circuit, auxiliary relay circuit, and this 24 volt DC or sometimes 48 volt DC we are using for the alarm indication circuit as well as various auxiliary relay. The relay which we have used, the relay itself needs a power supply. That power supply either 48 volt or 24 volt. Similarly, we use various transducer in the switchgear for the conversion of the various parameters. Those transducer also we can withstand only 24 volt DC or 48 volt DC, most of the transducers. Similarly, the alarms annunciator which is available in the market, that could be withstand only maximum 12 volt, 24 volt or maximum 48 volt. So that's why this, in addition to the 120 volt electrical control DC supply, we need another level, lower level of control voltage supply also for the various transducer, auxiliary relay, main relays, as well as these annunciators. For that purpose, we are considering as 24 volt DC supply. This 24 volt DC, this is a positive, this is a negative. Now, when we want to sense any of the normal healthy condition, we have to take the signal from the respective device. Now, here breaker auxiliary contact, we have already discussed about the breaker auxiliary contact. Breaker has auxiliary contact, normally NC contact as well as NO contact. NC contact indicate the breaker is off condition, and when you use NO contact, the moment breaker, this contact start as NC or NO in a breaker open condition. The moment breaker changes position from open to close, immediately this contact position get changed. So when the breaker is open, NC contact will give the signal healthy condition. That's why we have used a breaker. It is a breaker NC auxiliary contact. This contact normally NC contact we designate by 52B. 52 is a breaker tag as per ANSI, and B means it is NC contact. So breaker NC contact is coming. Then suppose this part you forget at this moment. Suppose this is the LED. So what will happen? Immediately the power will come and it goes through the LED. So LED will lit up, but this is a 24 volt. This voltage we cannot inject to the LEDs. So these LEDs when lit, when this contact is NC, that means when the breaker is off, immediately this contact is NC, then the current will flow through the LED, it will go and this LED will light up, so it will indicate breaker is off. Now, as this LED cannot withstand more than 3 volt, so we have to drop this voltage, this 24 volt, rest of the voltage to be dropped. In the old, there are two ways we can do. We can use a ballast resistor. We can calculate the resistor value and then we can use the LEDs over here. So this ballast resistor we can design in such a way, out of this, suppose we can design this LED for 2 volt, then balance 22 volt will be dropped across the resistor. And this resistor also limit the current of the LEDs. That is one way we can do that. That is, in that case, we use the LEDs like in this way. This is the LED. Instead of this device, we use this resistor. It's called ballast resistor. This is one of the way we can design. That means this part, how does it look? It will be looking like this. And then it will coming over here. So this device is replaced by this ballast resistor. The resistor value we can calculate based on the applied voltage and the withstand capacity of the LEDs. So the moment this is on, this up. But instead of ballast resistor, we use a special type of diode. It is called, this diode is a with constant current diode. Means it will give a constant current continuously. Whatever the voltage, if the voltage within this operating range, the current through the diode will be constant. This current is called, now it is actually not the diode, it is actually transistor. We call it junction field effect transistor, ZEFT, JFET. This is a junction field effect transistor. This is a constant current. It operates always when it works it works on the constant current. So this device limit the voltage as well as it will limit the current and allow to flow the constant current as per the rating of the LEDs. This is called constant current diode or constant current device. That device is called junction field. It is actually a junction field effect transistor. You know, this transistor has a two, that is a gate drive, this is a source, this is a gate, and this is your drain. So this, through this jet, we can use this constant current. So we use a jet over here instead of balance resistor, which will allow the constant current flow through the LED when this contact is NC. So breaker off status we can use through this constant current drive diode in series with the LEDs. Okay. So this is condition representing breaker off status. Similarly, the breaker NO contact, 52A contact, this will indicate the breaker closed condition. The moment breaker get closed, immediately what will happen? This contact become NC. NO will convert to NC and it become NO. So this indication lamp will go and then indication lamp will come up. The moment breaker get closed, this NO contact will become NC and immediately same way this LED will get power and this LED will lead up, that will indicate breaker on status. Now let us come to the circuit breaker healthy operation. Circuit breaker is healthy, breaker is on, and there is no abnormal condition in the circuit that is to be monitored. How we monitor the abnormal condition in the circuit? We have seen if there is a fault in the circuit, then what will happen? Lockout relay will, there the protection relay will operate. The protection relay's auxiliary contact we use for the lockout relay operation, and the lockout relay contact we use for the to identify or trip the circuit breaker. So if this lockout relay has not operated, in that case that indicates that there is no abnormal condition in the circuit, that the circuit is operating on healthy condition. That means the circuit breaker or the circuit is operating on healthy condition or circuit breaker not tripped on fault. That condition if we monitor, that will show that this circuit is in healthy condition. So that means, so circuit is in fault condition ultimately represented by the lockout relay. So we use the lockout relay NC contact. The moment lockout relay operates, this NC contact will open, then immediately signal will not be passing. But if we use the NC contact till the lockout relay is not operating, this healthy condition will be monitored. So if we use only one lockout relay, in that case we have only one NC contact we use in this way. This NC contact is passing the, allowing the current signal to pass through the lamp. So this is your current drive module, and then it's passing through the LED is going. So we get this lamp. But if we use multiple lockout relay, then those multiple lockout relay NC contact to be connected in series. We have to keep in mind. So this will be, suppose there is another lockout relay. So this is 86.1, this is 86.2. In that case, if any of the lockout relay operate, immediately this contact will open and immediately the LED will goes off. So when the LED goes off means it indicates there is a abnormal condition in the circuit. But till the LED is on, that indicate the circuit is in healthy condition, because when both are on, then only when both the lockout relay has not operated, then only LED will on. If any of the lockout relay operate, immediately those corresponding that relay contact will get open. Immediately this circuit will be discontinued. So this LED will indicate that the circuit breaker or the electrical circuit is operating in healthy condition. So these are the three indication lamp. Now here normally I have said that healthy condition we monitor by the green lamp. But sometimes some of the customer they want when the breaker is on means circuit is energized. So if anything somebody want to do something that will cause a danger. That's why this lamp breaker on status we represent by the red color lamp, and this off condition we represent by green color, and this is also green color means there is no abnormal condition. So only the breaker on status, some of the customer they prefer to as a red color to indicate that circuit is charged. So somebody should not do any operation on this circuit without proper permit. So indicate that is considered as a danger, give a danger notice to operator or the operating team that this circuit is charged, so don't touch the circuit. So indicate that thing. Sometimes this on breaker on status we monitor by the red color lamp, and this we monitor by the green color lamp. These are the three indications we have discussed. Now there is another abnormal condition can take place. We have already said that tip circuit supervision is important. So tip circuit supervision, this tip circuit, we have seen that tip circuit supervision relay is always energized. When the tip circuit is healthy, either in on condition or off condition, tip circuit supervision relay is energized. If you want to know this, please refer to our tip circuit supervision, that is tripping scheme or trip schematic video that will give how the tip circuit supervision relay is continuously energized either in on or off condition. So this tip circuit supervision relay NO contact we are using here, as the relay is always energized. So in the energized condition, this contact is NC. So immediately it will get in power through this. So it will monitor, this indication lamp will monitor the tip circuit supervision. Tip circuit supervision relay is energized and tip circuit is healthy. Similarly, another important parameter we need to monitor, we said that spring charge mechanism is in healthy condition. If the spring charge mechanism is not healthy condition and in unhealthy condition, if we close the breaker, then breaker will unable to trip because spring is not charged. So that's why spring charging mechanism in healthy condition also to be monitored. By the spring charging, we have said that there is an auxiliary relay in these actuators. After the actuator, when the actuator is operating or the spring is charged, there is auxiliary contact. That auxiliary contact, when it is fully charged, the NO contact will convert it to NC. That NC contact 52S, this is a 52S NC contact we can use the moment breaker is fully charged. This normal condition, when it is not charged, it is NO condition. When it is not charged, it is in NO condition. The moment breaker spring is getting fully charged, it becomes NC, and that NC contact will give the spring is circuit breaker spring is fully charged. These are the 5 parameters normally we represent by indication lamps. So this indication lamp actually not only LED, it is LED in series with a constant current drive solid state device which is called JEPT, or maybe it is another device, or otherwise we have to use a balance resistor. In addition to this, I am deleting, suppose this part I am deleting it. So suppose in addition to this, in case of SF6 circuit breaker, we measure the SF6 gas pressure. We have already told in the tripping scheme and closing scheme, SF6 gas is continuously monitored by the pressure switch. There is a 3 level of pressure switch. One is a high, SF6 gas pressure is high, that is one level. Another level, SF6 gas pressure is low, another is low. For that there is a pressure switch. Those pressure switch we call KP high. KP high means SF6 pressure is high, KP high is one switch, and then KPL, there is another switch, and KPLL, low switch. So if it is a very low, so normally we use the KPL and KPLL. If we use these two switches, or if has a auxiliary 3 contact, sometimes if this is auxiliary contact is not available, then what we do? We use a auxiliary relay. That for this 3 parameter we can use 3 auxiliary relay. That auxiliary relay contact we connect in series, NC contact. This when it is in healthy condition, when the switch has not operated, that position NC contact will connect in series. So if any of the switches operate, then immediately that contact will become open. Suppose this is NC contact 1, this is another NC contact, this is another. Suppose this is a KPA switch auxiliary contact, KPL switch auxiliary contact, and KPLL switch auxiliary contact. So these 3 contacts we connect in series. So if suddenly SF6 gas pressure goes high, then immediately this switch will contact will open. Immediately this indication lamp will lead off. If gas pressure low, then this become open. Immediately it will, the LEDs will go off. So this in this way, these 3 switch auxiliary contact or 3 auxiliary relay activated by this master switch is used. Then those auxiliary relay contact we use connected in series NC contact, and that will give the SF6 pressure healthy. SF6 gas pressure is healthy. This integration will give the SF6 gas pressure healthy. The moment this lamp goes off, we understand that SF6 gas pressure is not healthy. So any of this has operated. So according to we can take the necessary action. These are the indications we use for the switchgear normally to monitor the healthy condition. Now these LEDs, whether the LEDs itself, suppose suddenly this switch, these LEDs and these LEDs goes off, how? If this parameter actuate. In addition to this, if this LED burned out, then also the light will goes up. So we don't know whether when the light is goes off, when the LED is getting off, in that case LED is getting off due to the actual fault or due to the fault in the LED itself. So we need to monitor these LEDs regularly. That means normally in every week you can check this LED's operation. That's why we provide in the switchgear another push button for that test purpose, the LED test push button. So that LED test push button we put in parallel to this actuating parameters. These are the actuating parameters. In parallel to this, in this actuating parameter, we put one push button. The moment this push button press, then what is happening? With this push button, we connect diodes in the same way, current limiting diode. This, it is a similar type of diode. We connect in parallel on each. You see, this is one diode, this is one diode, all are connected and in parallel to this diode. And but these diodes are getting activated only when this push button is, the moment the push button operated, immediately you see this is the forward bias. The moment the diode forward bias, immediately the current will pass through this. This LED will be on. Similarly, when you press this button is pressed, so all this circuit is getting energized. You see here, then it is coming through this and it is passing through this. And because all these things, these parameters are not activated. So at that time, if it is a NO contact, that means this is not activating. And if you use a NC contact, that is activating. So activating means LEDs are all right, but the LEDs which we are using for the NO contact, that LEDs will not be knowing what is happening. So through this indication push button, we can test the LEDs condition by putting another parallel diode with this original current constant current drive jet. So we use another jet over here in parallel the constant current drive, which is connected in series with these LEDs, and that will be connected through the push button. So the moment you press the push button, immediately this current will pass through the LED will operating. That will indicate that LEDs are healthy condition. If any of the LEDs goes off, immediately we can test with this LED, with this parameter, whether there is actually fault or the LED is faulty. Okay, this is about the indication to monitor the healthy condition of the switchgear. I am deleting this part. Then we will be coming to the next part. Next part is the annunciation part. Now this annunciation normally we use to monitor the abnormal condition of the switchgear operation. Now the abnormal condition, what are the various abnormal condition? So first abnormal condition is, suppose the breaker is tripped on fault. That is the abnormal condition. There is a fault on the circuit. So breaker trip, we have to monitor the breaker is tripped. So breaker trip is monitoring by how? We monitor the breaker trip or a breaker circuit breaker or the circuit's abnormal operation by protection relay, as I discussed before. So protection relay means ultimately it stands for the lockout relay. So if I use only one lockout relay, suppose this is one of the lockout relay 86. So 86 contact, if we use this, the moment 86 operate, immediately this contact is NC, then immediately this is a resistor, and then it is coming, this is the LEDs. This LEDs is going over here, so the current is flowing through the LEDs. So the LED will glow. This will indicate that circuit, this particular circuit protection system has operated. Now if we use multiple lockout relay, then those multiple lockout relay NO contact will be connected in parallel. In the case of indication we use in series, but here we are operating abnormal condition NO contact. As we are using NO contact, will be connected in parallel. So normally all this contact is open, so this indication lamp is not on. The moment any of the lockout relay, suppose this is 86.1, 86.2, if any of the lockout relay operated, immediately this LED, this resistor will allow the current. This is the balanced resistor I have shown as alternative. In the previous indication we have used a ZEP or the constant current device, but here we are using balanced resistor. So this balanced resistor is connected in series with the LEDs and that will flow the current. So the moment this contact NC, immediately it will flow. This will indicate that protection system operated, means there is a fault on the electrical circuit. So this parameter is providing the lockout relay operated or electrical system under fault, or there is a electrical fault, lockout operated or HB fault or electrical fault will indicate by this. Now question is, you see here the module how we have drawn, we have put on resistor, then we put a LED, yeah, this LED, this is a forward bias LEDs, and then we put another reverse bias diodes also, okay. reverse bias diode we connect over here, okay, in parallel to this. This reverse bias diode actually protecting these LEDs. If there is a voltage change or there is a ripple or any other current is flowing, ripple means it is a AC and there is a multiple different frequency AC that we can pass the current. If that current passing through this will cause the damage to the LEDs. So we give a reverse path to pass the negative part of that current flowing through the LEDs through this to get a drain. Okay, so this is one function. Second, all this damping current is passed through the reverse bias diode. Another, if there is suddenly over voltage come over here, then immediately to avoid the suppress that over voltage, this reverse bias diode is operating. So the reverse bias diode will be operating on over voltage and it will protect this diode, this LEDs. That is another function of the reverse bias diode connected in parallel to the LEDs. So this actually, what is happening, it is actually mounted on the PCB. I have already told this is the annunciator. So this annunciator is not discrete. This way we do not make the circuit in the switchgear. This is actually part of one annunciator. Inside the annunciator, all these solid state devices are put by on a PCB. It is soldered. So I'll discuss that part separately. So this is a lockout relay operated protection fault we monitor. This is one of the abnormal condition. Second abnormal condition, what could be? Suppose this is we are giving a control supply to the switchgear. Various control supply I have already told. 120 volt DC control supply, 24 volt control supply, maybe 48 volt control supply. Then there is a various auxiliary supply. AC supply is available. Auxiliary supply like a lighting circuit supply is there. So heater circuit supply is there. Some of the device may need a AC auxiliary supply. All this supply, how we provide? We provide through the MCB. We have seen now, suppose this is a tip circuit. In the tip circuit, we have the MCB, right? This is a two-pole MCB connected. So when this MCB got tripped, this MCB has auxiliary contact, NO or NC. We can make one NO, one NC contact. This contact is not normally actuated. The moment this MCB tripped, this will be operating. So the moment the MCB tripped, this NO become NC and this NC become NO. So if we use this NO contact over here, so the moment this MCB trip, immediately this NO become NC, immediately this will be indicating, this indication lamp will come and immediately horn will be sound. That I am coming back to how the horn will be sounding. Horn is also connected over here. So the moment, so this MCB operated or MCB trip indicate that there is a fault in the MCB circuit. Similarly, this is a control supply fail. Then the third condition which may consider we have already sent the FCS switch gap. If the spring is not charged, suppose the spring is not charged or spring charging mechanism fail, then also it is a danger. So the spring charging mechanism we monitor by 52S. This 52S, if we use a 52S NO contact, the moment, NC contact, the moment spring is charged, it become open. But if the spring is not charged, that means it is NC, immediately it will give alarm. Immediately this circuit will be getting and it will be giving alarm. So this will monitor the spring charging condition. Then we have already, we have seen that in case of trip circuit supervision, if the trip circuit is not healthy, then what will happen? We cannot trip the breaker. So trip circuit healthy condition, if the trip circuit fail, immediately 95 relay will drop out. So if we use a 95 NC contact, 95 NC contact will give a trip condition, trip circuit unhealthy condition. The moment this indication lamp operate, this in the annunciator we understand that trip circuit is unhealthy condition, means the 95 relay has dropped out. That is also we can monitor in this way. Similarly, if the SFC's gas pressure is not normal, SFC's gas pressure is unhealthy, so immediately what will happen? Immediately we cannot operate the switchgear. So switchgear unhealthy, SF6 condition is not healthy, that to be monitored. How we monitor this? We have used that control switch, we have already discussed. So if we use that control switch in parallel, so these are the SF6 gas pressure not healthy. So this is the NO contact of this. 3 NO contact actually we connect in parallel. These are the NO contact. Normally it is when it is healthy, it is NO contact. The moment any of the switch actuate, immediately it become NC. That means when this pressure goes low or go high or low, immediately the corresponding switch will get NC, it become NC. When it is healthy, it is NO. The moment it is not healthy, this contact will become NC, and that is connected in parallel. So in normal condition, when the switchgear is operating, all the switches are healthy, so it become all are NO. So no signal is coming to the. There is a lamp over here. Okay, this is a lamp and this is a reverse biased ZEPT connected over here, and this is a balance resistor. So this is a, in this way it is working. But the moment this switch is closed, the moment this switch fail, any of the switch is operating immediately, when the pressure is abnormal, this NO contact become NC and corresponding lamp will go, and that is the reverse bias diode will be in parallel. So this way we can monitor this thing. The reverse, this SFC's gas pressure is not healthy. Similarly, suppose if we want to monitor any other parameter, suppose there is a tripping in the downstream, so that need to be monitored over here. If we want to that, in that case from the downstream there is a lockout relay. That lockout relay contact we can bring over here and we can connect over here. So if the downstream lockout relay operator, the downstream, suppose this is a switch gear is feeding power to another feeder downstream. So in that case, downstream condition we need to monitor. So we can connect the downstream contact over here. So it will indicate that downstream is faulty. So that also we can monitor over here. Suppose this is the feeder giving power supply to a transformer. In that case, transformer operation is in healthy condition, that also to be monitored. How we can monitor this? We have seen in the case of transformer, there are various abnormal conditions. The transformer has various devices. Suppose the transformer is more than 5 MVA. So there are various devices. There is a Bockel's relay, there is a oil temperature indicator, there is a oil level indicator, there is a pressure relief device. All these things are there. So if any of the parameter does not maintain the normal condition, then corresponding device will give auxiliary contact. If we want to monitor that thing, then those contact we can bring over here and we can monitor it. Suppose we want to monitor the Bockel's relay operated. If it is a then the Bockel's relay auxiliary contact we can connect over here. This LED, this is LED, and this is a balance resistor, and then it is a reverse bias diode to protect this device from the over voltage or over stress. So this will be giving the, suppose this is a Bockel's relay contact. The moment Bockel's relay operates become NC, it will give a indication, and it's connected to the horn system, it will give horn. So it is a Bockel's operated. Suppose similarly there is a temperature trip. There is a temperature device on the transformer. So if the temperature indicator, if the temperature goes above the normal level, then immediately that contact will become NC and it will give similarly another indication over here in the alarm system. Similarly, it is a temperature alarm. Okay, temperature trip. Similarly, Bockel's can give a alarm. If we use a low level Bockel's, then it is a Bockel's will give the alarm. If temperature is not the trip level but alarm level, then we can get temperature alarm. That is also we can get another. Similarly, oil level. Suppose the oil level is low. So oil level low, we can get an alarm over here in this way. And if the oil level is very, very low, then it go to trip. Then oil level is very, very low, we can get another indication. But if we do not have so many windows, what we can do? We can make parallel of all this. And then we'll use only one indication lamp, which will give the transformer trouble. Transformer trouble. So when we see this indication lamp, then somebody will go to the transformer, then they will check all the device, which device has operated. So from that they can manage it. So this is another way, shortcut way we can do if we don't have the enough windows in the annunciator. Now this annunciator, this annunciator is a solid state device, in a modular form. This annunciator, not only this indication lamp, it has also a horn. Nowadays, in the old days, when we use the discrete circuit, we use a separate relay, one of the relay. We use this type of conventional circuit. In the old days, what we used to do, in the old days for the annunciation, we do in this way. We use a ballast resistor, okay, and then we use the indication lamp. That is a filament type indication lamp on the window. It is a small window, control a small panel. In the panel there is a ballast resistor, and then this is connected. This is one of the window indicating this is your lamp. Okay, so this window is indicating by this by this your lamp, and then this is your actuating parameters. Okay, this is your actuating parameters is connected over here. I can draw it slightly downward, then it will be easy to make out. So this is your balance resistor and this is your indication lamp, okay, and it is connected to the negative bus. Suppose this way. And what is happening there, we put one auxiliary relay over here with a push button, okay. This is a NC push button. It is called reset push button, okay, and this relay is a R relay. It is connected over here, and this is a actuating parameter. Suppose this is your indication lamp for the lockout operated. Suppose it is 86. So 86 is connected over here. So the moment 86 operated, this lockout, this R relay will be activating and the lamp will go. This R relay contact, what we do, we put a horn over here. Okay, this is our horn. Okay, this is a horn. This is a horn. So the moment this, suppose this is one parameter, similarly, we can connect a multiple parameter over here. So this is another lamp. This is another lamp. As we have a multiple number of functions, we can use this way. All this function we can put over here, but through a relay. So the moment any of the function operate, suppose this is operating. So how it is operating? Current is flowing through this, and then it is going through this. This indication lamp will operating. Immediately this relay picked up. The relay contact is NC. The horn will blow. This horn, and then we actually in this horn there is another push button. That's a horn off. Okay, this is another NC push button. This is a horn off or sound off, you can say horn off, or you can say it is acknowledge button. Okay, so the moment any of the function operate, how in the old days how it is work, through the relay the power current is flowing, so the indication lamp is operating, relay picked up, the relay contact is became NC, this is driving the horn. So horn is sounding, at the same time the lamp is remain on. And here is another thing, along in parallel to this, we put one relay contact to seal the relay. This is a R relay contact in parallel. So the moment this is this function is activating, immediately the corresponding lamp is glowing and the horn is also sounding. Now somebody will come back, what has happened? Immediately what you will do, you will press the push button. So the moment you press this push button, then immediately this circuit will be disconnected. So horn will going off. But the lamp is remain glowing because this relay is still picked up, the function is not cleared. The moment this function 86 is cleared, still the lamp will not glow. Lamp will be maintaining the circuit, the R relay will be passing power through this because it is a sealed through this. So now still the lamp has cut off, but relay is not drop out. So what I have to do, I have to press the reset button. The moment I press the reset button, immediately you see the R relay, though this contact was NC, the moment I press this contact, and if the fault is clear, then this will not allow this R relay. The moment I press the reset button, this push button become NO. The moment push button become NO, then current cannot flow through this, and the relay will draw me. This become normal, so circuit will become normal. This is in the old days we use in this way the horn, but nowadays all this thing is not there. Now we are using annunciator. This annunciator is solid state digital device. You know the present day annunciator, depending on the number of ways, it has a various input and output card. Suppose I am using a 10 ways annunciator. In the 10 way annunciator, I have a card, input card. This annunciator, it is a small window. Inside a small module, this module, and inside the module there is a small window. Suppose it is a 12 ways. So what will happen? This will be 12 small windows here. Okay. Suppose this is a 16 ways. So this is one window, this is one window, this is one window, like a 16 windows. Each window for one function. So there is a lamp over here and there is a horn output. So when any of the function operate, we can see from here, it has this horn is, this light is glowing. Now this nowadays most modern annunciator, this lamp has a various ways we can flash the lamp, as well as we can make it a steady on or off. This lamp can be, we can program this annunciator in that way. Nowadays in the digital annunciator, this indication lamp can be a steady one. It could be flash, and flashing also we can make high speed flash, low speed flash. That all this thing we can program in the digital annunciator. So this digital annunciator, if you look into, it has a input card and the output card. In the input card, what is happening? In the input card, it is accepting all the input signal. So if you say this is the input signal, means that all the signal which is coming from the field. So is a 1-1 function. Suppose this is your 86 lockout relay contact coming over here. So in the input card, you can see this is the card. It has a terminals. Okay. So these are the it is a potential vary contact. So these are the two terminal for this potential vary contact. Some two wire is coming from 86 lockout relay. There is a contact. This 86 contact is in the switchgear in the relay lockout relay. From that, these wires are coming. Two wires are coming. So these wires are coming connected over here. This is the one input. This is input number 1. Similarly, this is the input number 2. This way we can go up to input number. Suppose it is a 12 way or 16 way. So 16 inputs are there. Okay. Similarly, in this is the total annunciator is like this. Okay. This is the part of annunciator. Similarly, here is the output card. In this output card, actually what is happening, in the output card there is a output small RED, read relays are there. The read relay we can, if there is a 16 input, there are 16 REDs, read relay, RED, read small relays are here. This 16, this is a output, this is called output. Suppose it is output 1, output 2, output 3 like this, a small read relay. This read relay has a contact. Suppose it is NO and NC contact. So if we use the NO contact, suppose this is one of the NO contact. Okay. It is giving one NO contact. This NO contact we can wire up to the indication lamp. So what is happening? There is a LEDs over here. This LEDs is coming over here this way. And this annunciator has a 24 volt separate supply we have to give to annunciator. All this output contact will get power from this 20 internal distribution is there. So this 20 volt supply will come over here. The moment this output contact is energized, immediately LED will glow and it will show that output number 1 is activating. Now output number 1, what is showing, that we can also configure. Suppose input 1 is configured for 86. This is input 1 is 86 coming. So I can configure output 1 also for 86. It is not mandatory that output what to be configured for this. Suppose I want the output 6 to be configured for input 1. So I will configure this one for the lockout relay operated. That I can do that. I can interchange the output with respect to input, but we have to program this annunciator in that way. So this is the way present day annunciator is working, and this annunciator has a 3 push button. Okay, there is on the annunciator you will see there is a 3 push button. One push button, the moment any of the, now how this annunciator working, the moment any of the input is high, the corresponding output which is programmed, suppose input 1 is 86 and output 1 I configured for 86, immediately this indication lamp will be, most modern annunciator, it will be flashing, and the moment output 1 is high, it is giving, this output relay also giving one contact to the alarm, to the horn circuit. The horn will be immediately, suppose this has a 2 contact, one contact giving to indication, another contact is going to the horn. This from all output, one contact is going to the horn, that is internally on the PCB, it is already soldered. So this output contact commonly it is going to the horn, so immediately horn will be activated. And the horn circuit is disconnected by push button. So like before, the moment I press the push button, immediately horn will be a stop. So this, on this annunciator you can see there is a 3 push button. One push button is a horn stop or the sound off. Then another push button is a acknowledgement. Acknowledgement means you press that acknowledge button or silence button, or other way you can say one push button is a silence push button, then another push button is a acknowledgement push button, another is a reset push button. Silence push button, the moment you press the silence push button, horn will go off, but the lamp will be flashing. So that will indicate which fault has taken place. Then the moment you acknowledge it, then the horn will be, light will be steady, it will not be flashing, it will be steady. Then you find out what is the problem. Once you clear the fault, that means when this contact back to normal, then you have to press the reset push button, then there will be a reset push button on that annunciator that will bring back the system normal. So there will be 3 push buttons. One is a silence push button, one is the acknowledgement push button, another push button is your reset push button. Okay. So one push button is a silence push button, silence push button, silence. Another push button, there is one push button over here. Okay, then another push button is your acknowledge push button, and then third push button is your reset push button. These are the three push button, and then there is a test push button also over here. Test push button, as we say, the lamp test, all the lamp we can test by the test push button. These four push buttons, some annunciator maybe three push button, while the flashing lamp is not there, there is only two. One is a silence push button, another is a reset push button. Acknowledgement push button is not there because the lamps are a steady lamp always. The moment any of the fault take place, horn will be sounding and the lamp will be glowing. So the moment you press the silence, horn will go up, but the light will be there, indication lamp will be on. The moment you clear this lamp fault condition, then you press the reset button, the lamp will goes off. And there is a test push button for the testing the indication circuit, the way we have drawn the circuit for the indication circuit. But all these things are inbuilt with the annunciator with the soldering connection. It is a PCBs. Okay. So these are the threes, and then this annunciator also has a 24-volt supply, and this annunciator can give the already so all the output will has one contact is connected to the horn. How it was actually connected? Suppose all this read relay one NO contact you connected in parallel. Okay, all connected in parallel, and then it is going to the horn. It is going to the horn. Okay, this is the horn going to the horn, and then this is going to the 24-volt negative. Okay, it is inside it internally distributed, and it is going to the positive side of the 24-volt DC inside the annunciator. So when any of the output relay operating, immediately it will indication lamp will be on, and that will give the horn. And here is a silence push button. This push button which we tell no silence. This push button is located actually electrically connected inside the PCB like this. The moment you press it, immediately it will be disconnected, and so silence will be off. And the reset push button, we have shown this indication lamp in connected in parallel with this, that will give this your reset push button. And test push button we have already discussed. So present day annunciator is like this. Now in addition to this present day annunciator, we said that most advanced annunciator, this lamp is not steady, it is a flashing mode, and the flashing is also a fast flash and this less flash. Flashing will be very high speed and flashing will be slow speed. So why we using this thing? The most advanced annunciator, we are providing all this facility to understand that which protection has operated or which abnormal condition has come first to the electrical system. Because you know sometime any of the one of the fault or any one of the abnormal condition can activate multiple abnormal functions. In that case, multiple lamps, suppose we have shown all these things. Suppose there is a 1, 2, 3. And each has one indication lamp is glowing over here, right? So when this function operated, immediately it will glow and the horn will off. But sometimes it happened for this fault, other fault also taking place. So in that case, what will happen? All these will be on. So if you go to the annunciator, you will not able to make out actually which has taken place first. First it has taken place and that is cascaded that thing to the other, or this has come first. To identify that who is operating fast, we put this feature fast flashing, quick flashing. Quick flashing lamps is only the abnormal condition which comes first. That indication lamp will be fast flashing, and the other abnormal condition which has comes afterwards on the same event, that will flashing slowly. So when I go to the indication on the annunciator, from the flashing speed, I can make out which function, which abnormal has taken place first, and then which has taken place afterwards. To identify that thing, this fast flashing and slow flashing indication lamps are there. So in that case, the moment you come to this and you press the silence button, immediately what will happen? Horn will go off, and then what will happen? But the lamps will be flashing. Now the moment you press the acknowledgement, then all this lamp will become normal. It will be on, but it is steady on. Then you reset it, then all the lamp will go off. Okay, these are the way nowadays new generation annunciator is working. Okay, so this is about the annunciation. So the annunciator we are using for the abnormal monitoring the abnormal condition, and indication circuits we are using to monitor the healthy operation of the switchgear. These are the two parts. And these circuits, it has a different configuration, you can use it. Nowadays, every day it is getting changed. You can see different circuits, but keep in mind the indications for the healthy operation and unhealthy condition is operating by the annunciators. And the LEDs nowadays in most of the no filament lamps using, we are using LEDs. And LEDs, when you use for the indication lamp, we have to use either ballast resistor or a constant current drive device, so that it will flow the constant current through the LEDs. And for the test purpose of the LEDs, we put another same type of diodes in parallel to the current dividing device to test the circuit. And in the case of alarm circuit, you can use in the same way on the PCB, or you can use a ballast resistor. But if you use a ballast resistor, then for protecting the LEDs from the reverse bias or external high voltage stress or suppressed current, you have to use an anti-bias or the reverse bias diode in parallel to the LEDs. So that is in a brief, and then depending on the requirement you can design it. But normally if we have a 6 number indication lamps, we can normally we consider 25% extra windows, minimum 1, so that in future if some additional indications are required, the lamps are available, but that will be SPL lamps. Okay. And secondly, in the annunciator also, suppose I am using only 10 ways of annunciator. 10 ways of annunciation, I have 10 number annunciation, then in that case I will go maybe 16 ways annunciator, so that, or 12 ways annunciator, so that some 20% extra windows will be available for future connection. That way you have to select the indication and annunciation. For indication annunciation, always keep in mind at least 25% additional windows or additional indication lamp should be available on the panel for future use, but minimum 1. That is the normally we specify in this way. This is in brief of the alarm and indication requirement of the switchgear. And with this, I am closing to this video number 7. Please go through this and keep it up. And if you have any queries, please raise to me. And thank you very much for going through these videos and your support. Thank you very much indeed. Thank you.